Okay, today's lesson is on adding and subtracting polynomial expressions. So first of all, an expression is different from an equation in the sense that it does not have an equal sign. Polynomials are just multiple terms separated by addition or subtraction signs. So what we're doing is essentially what you did in IM1. We are combining like terms. Okay, so in order for terms to be like terms, there are two qualifications we need to have. We need to have the same variable. Oops. And those variables have to have the same exponent. Okay, so like terms have the same variable and the same exponent. We will be combining the coefficients, so the numbers out in front of those variables. Now, it might be helpful to have multiple colors with you so that you can highlight and underline what you need to as we go through. So let's look at our first example. So we have 5x squared plus 2x minus 1, and then 4x squared, plus 4x squared minus x plus 2. Now, when we are writing and combining like terms, we need to write it in standard form, which means we have the highest exponent first, and we go down to the constant, so in descending order. So the highest exponent that I see is an x squared. I see an x squared there, and an x squared there. So 5 plus 4, because you're adding the coefficient out front, is 9, and then your x squared stays. The next highest exponent that I see is a x, so 2x minus that's a 1x, so 2 minus 1 is 1. I'm just going to write it as plus x. If you put a 1 in front, that's fine. And then my last terms are my constants, so negative 1 plus 2 is a positive 1. When I combine like terms, my final answer is 9x squared plus x plus 1. Let's look at another example. So 3y to the third plus 2y plus 1 plus y squared minus 1. The highest term that I see here is this 3y to the third. Now there are no other 3y's to the third, so I'm just going to rewrite that. From there I see a y squared. It's the only y squared I see, so I'm going to rewrite that as well. Then I have a y, so I'm going to plus 2y. Again, there's nothing to combine it with, so you rewrite it. And finally, I have a positive 1 minus 1. Those terms end up canceling, so my final answer is 3y to the third plus y squared plus 2y. I'm going to give you two problems that I'd like you to try, so once I write these two problems, please pause the video so that you have a second to try them on your own. Again, here are the two problems I would like you to try. Pause the video at this time and try these two problems. Okay, now that you've had a second to do those two problems, we are going to again combine like terms. So my highest exponent in number 3 would be these cubes. So I have a negative 1x cubed and a positive 2x cubed. Negative 1 plus 2 is a positive 1x cubed. Then I have this lonely x squared, so I'm going to rewrite that negative x squared. Next is my x's. I have a negative 2x and a positive 2x. Negative 2 plus 2 cancel out. And then lastly, I have this negative 1 at the end. So your final answer should be x to the third minus x squared minus 1. For number 4, If I combine my x's, I have 1x plus 4x is 5x. And -1 minus 6 is a -7. So 5x minus 7 is your answer there. These were all addition problems, so you'll notice that there was an addition sign in between both sets of polynomials. Now we're going to look at subtraction. Subtraction is very similar. We have one additional step that we have to take care of before we can subtract. Or before we can combine like terms is probably better. So you'll notice now that there is a subtraction sign in between the two sets of polynomials. We need to distribute this -1 to everything behind it before we combine like terms. So I'm going to start by rewriting my first set. So y squared plus y minus 1. And then when I distribute, really what's happening is you're changing the sign, because a negative times a negative becomes a positive 2y squared. A negative times a positive is a -y, and a negative times a positive is a -1. At this point, it is exactly like it was for addition. You take your highest exponent and you combine like terms. So I have a y squared plus 2y squared for a total of 3y squared. I have y minus y. Those are going to cancel out. And then lastly, I have a -1 minus 1 for a -2. So 3y squared minus 2 will be your final answer there. Let's try one more together. And then I'm going to give you two to try on your own. So again, before we can do anything, we have to distribute this -1 to both terms. So I'm going to rewrite 8y minus 7, and I now have -1 plus 3y when I distribute that -1. When I combine like terms, 8y plus 3y is 11y, and -7 minus 1 gives me a -8. All right, why don't you try these two? So again, take a second and pause the video and attempt these two problems. All right, now that you've had a chance to try, remember, you needed to distribute that negative sign first. So if I rewrite, I have a -x cubed minus 2x minus 1, and then a positive x cubed minus 2x minus 1. My x cubes are similar, except -1 plus 1 cancel out. I then have a -2x minus 2x, so -2 minus 2 is a -4x. And then lastly, we have -1 minus 1, which gives me a -2. And then finally, for number 8, I'm going to rewrite what I have and then distribute that negative. So that's a positive 2q squared, a -q, and a positive 4. Highest exponent is a 2, so 2q squared plus 2q squared, 2 plus 2 is 4q squared. -q minus q, -1 minus 1 is a -2q. And then -8 plus 4 is a -4. So 4q squared minus 2q minus 4 is your final answer.